In this video, we will configure persistence on our BIG-IP appliance. Now, before we do that, let me explain more about what this is and the different types and considerations to keep in mind. Now, the first question to really ask is, what is persistence? And here's what it is. So within your server pool, and depending on how your application works, you may require the client to stay connected to the same server once they connected to it within a pool, and to not be load balanced to a different server. Because by default, every client request for a single connection from a client will be load balanced based on the method among the servers in the pool. Using persistence can change that behavior. So for example, if persistence is set up on a virtual server, when the client connects to the web farm, or any kind of farm, for example, the virtual server will choose a server based on the load balancing method, least connections, round robin, whatever it could be. Then the BIG-IP will then keep track of that server that the client connected to, so it can know where to send other requests from that client for that active session. Now the question asked is, how does the BIG-IP and persistence track the source of the actual client? That is where the different types of persistence come into play, where the BIG-IP can keep track of the client and the server it connected to in the pool using one of these methods listed below. Now the main two that are often used is based on the IP address of the client, and the other is using HTTP cookies for web server farm environments. Let's talk about those two types a little bit further. For the first type, the BIG-IP can track the client using its IP address, or the source IP address, for how it is assigned to that user's computer. So with source IP persistence, when a client request reaches a server pool, the BIG-IP will select one server that the request will be sent to. And the BIG-IP will create a record called a persistence record based on the IP or the network from that client. So this record will contain details of the server in the pool that returning client request should go to, and not sending the client to a different server. So this record will expire after a particular date and time and be removed from the BIG-IP itself. So it is the mask itself that is used in the configuration to specify how a persistence record will be created and used. For example, if you use a mask of a /32, this means that the BIG-IP will create a persistence record for each host that accesses the server farm. So for example, if there are 100 hosts or clients that accesses the server farm, then the BIG-IP will create 100 persistence records. So this can consume a lot of unneeded resources. But if we set the mask to a /24, then this means that the BIG-IP will create a persistence record for each network based on the client's source IP when accessing the server farm. So for example, if there are 100 hosts that access our server farm and they're coming from the 10.67.78.0 network, then the BIG-IP will create only one persistence record for the 10.67.78.0 network, pointing to a single server in the pool. Now, if you want to use this persistence type, there are some considerations to keep in mind. If clients all originate behind the same NAT gateway, they could all have the same source address, which is common for PAT or NAT overload configurations, which is configured on many firewalls today. Now, this means that all clients from one site or company may communicate with a single server in the pool, which could overload its resources. So for example, let's say that you host an application that is being load balanced, and you need to make sure that each client stays connected to the same server in the pool, or the session itself could break. Well, let's say that half of your clients who will connect to the server farm exist from the same company behind a firewall or a router enabled for NAT. So let's say that there are 100 clients behind this firewall and they are accessing the web farm. Well, when they are communicating through this firewall, its address will be translated to the IP of 6778. This is the IP, the source IP for all clients that are initiating connections through the firewall. So when it reaches the big IP, and the big IP will see that, and it will create a persistence record, now based on the mask, but let's say that it's doing it based on the, based on /32 mask. So that means it will create a record of 6778, and of course it's load balanced to one of these servers. Let's say server 1. So that's the record that is created. So that means that all 100 clients are communicating directly only to server 1, because the big IP assumed that this is only one client and not 100 clients behind some NAT gateway. Therefore, if you have a use case of that, where you will have clients, many of your same clients behind the same kind of gateway, then you should probably avoid using this persistence type. The other persistence type is where the big IP can track the client using a created HTTP cookie that can be created on the big IP appliance. Now, using this type is only applicable for HTTP applications that uses cookies. So FTP, for example, doesn't use HTTP or cookies, so that type cannot be used. So with this particular persistence type, when the client connects to a web farm, then a cookie will be created and installed on the client. So the cookie itself will have some kind of a simple identifier like this, and that identifier will be created as a record on the big IP that allows it to know that this is pointing to server 1. So that means that when the client requests continue to go through the actual big IP appliance, then it knows by looking at the cookie ID to send that request or all future client requests to server 1. So that's how it actually does that. So this is great for internal client traffic that is accessing a web farm that could have a big IP in front of it. The HTTP cookie can be created in many ways depending on who wants to control how cookies are created. And this is determined by 3 modes. There is the insert mode, rewrite mode, and passive mode. So in insert mode, only the big IP itself creates a cookie that will be used by the client. It will contain the pool name and the pool member that will be encoded within the cookie itself. This is the identifier that I was using as the example before. And rewrite mode, this is where the server and the big IP together, they both create cookies. But in this case, the web server itself would create a blank cookie, and the big IP will rewrite the cookie with the details of the pool and the pool member, which would then be sent up to the client and installed. And with passive mode, this is where only the server creates the cookie that will be installed on the client. So in this case, the web server would create the cookie and the big IP will passively send it up to the client unchanged. So these are modes that are not specifically configurable on the big IP. Now, most environments will utilize insert mode because that is the only mode that involves configuring cookie management on the big IP. And this is all handled automatically by the big IP itself. There's no extra configuration needed, which you will see in the video lab. Where rewrite and passive mode, for those type of environments, this is where server engineers or server admins, they would need to manage how those cookies are created on the web server. So this will have less involvement on the big IP itself, especially for passive mode. So if you have an environment where the system administrators wants to create these cookies, then you're looking at one of these 2 modes here, likely the passive mode. But once again, insert mode is the most common. The main issues involved with persistence using cookies is usually with the client's computer itself, not the big IP appliance. If the client's computer disables cookies within their browser, that will result in the big IP not able to examine what server in the pool the client was connected to. So it's not recommended to disable cookies. A lot of websites rely on cookies. Another common issue is if the client's computer has the wrong time, because these cookies are time-stamped and they're set to expire at a specific time period. Having the wrong time can also create issues for the client connecting. So So these are considerations to keep in mind, that if there are issues, you want to troubleshoot more on the client itself than the big IP itself.